In today's lecture, we'll look more into the properties of logarithms, and in particular, how we can use the properties we defined last time to condense and expand logarithms into either simpler terms or into one log, where we can just evaluate it all at once. So remember, we have a couple properties of logarithms here. We have the product property that says if we have multiplication inside the log, we can split it up into two new logs, and that multiplication becomes addition. Similarly, we have the quotient property that says if we have division inside of the logarithm, we can split it up into two logs, and the division simplifies down to subtraction. And finally, we have the power property, which says if we have an exponent inside of the log, we can simplify this and bring that exponent outside and make it multiplication. So we take a log and we break it apart, and we can turn it into addition and subtraction, or we can go backwards. If we have two logs that have been added together, we can squish them together and just make one log with multiplication on the inside. With these rules, let's see how we can start to condense and expand logarithms by looking at a couple examples. So our goal will either be to take complicated logarithms and pull them apart into as easy to look at terms as we can, or to take logs that are very spread apart and try to condense them down so we can see exactly what's going on inside the logarithm. Now, we'll do this for 6 examples. And the first one wants us to expand log base 4 of 5x cubed times y. When we do these, we first look for the product property and the quotient property. And then once we've used product and quotient, we use the power property to make it even simpler. So we have the product and quotient here. And since we have a lot of multiplication on the inside, we can spread this out and make 3 logarithms. This will be log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Now we've gotten rid of all of the multiplication on the inside, so the next step is to use the power property and to pull any exponents outside, and then we'll be done. The only exponent we have is on the x cubed term, so this becomes log base 4 of 5 plus 3 times log base 4 of x plus log base 4 of y. We can't make this any simpler, so we've expanded it as much as we can. Let's move on to the next one. Now we have 2 logs, and we want to condense them together, and then we can look at what the quotient is on the inside and understand it a little bit better. When we're condensing, we go in reverse order. We start with the power property, and once we've pulled all our exponents inside, then we'll use the product and quotient to squish everything down. So multiplication on the outside will now become powers. The only multiplication we have is this times 2 right here. So this becomes the natural log of x plus 2 squared minus the natural log of x. So notice here that the entirety of what's inside the log gets squared. Not just the x and not just the 2, but it's x plus 2 all squared. Now that we've dealt with all of the exponents, we'll get rid of the addition and subtraction outside of the log. And since we have some subtraction right here, this will become division inside of the log once we looked at the product and the quotient. And our end result will be the natural log of x plus 2 squared divided by x. Whatever is first becomes the numerator, and whatever is being subtracted becomes the denominator. And now we've condensed this down. It's all inside one log, and we can see that this is actually taking x plus 2 squared and dividing by x. Let's do another example. Again, we're going to condense some logs, and we have two choices here. If we remember our order of operations, it says we should always take care of everything inside the parentheses first. So instead of doing the product property right away, let's deal with these two terms here, condense them down, and then we'll deal with things outside the parentheses. So, three log 3 of x is outside the parentheses, so we'll leave it alone. Plus 4 times, now we have subtraction on the inside, so this becomes division, log base 3 of y divided by z, and we've condensed one log. Now, the inside of the parentheses can't get any simpler, so we'll move on to our product property, which tells us to move the 3 and the 4 up, so this becomes log base 3 of x cubed plus log base 3 of y to the 4th divided by z to the 4th. Remember, when we move an exponent into a fraction, both the numerator and the denominator are going to get hit. So it's not y to the 4th divided by z, or y divided by z to the 4th. It's always y to the 4th divided by z to the 4th. Now that we've done all of the multiplication on the outside, we finish this off. Oops, this isn't product, this is power. We finish this off with our product and quotient rule. And the addition outside of the logarithm becomes multiplication on the inside. So this is log base 3 of x cubed times y to the 4th divided by z to the 4th. With multiplication, we can simply combine the numerators and we're happy. This has been simplified down to one log, and we can see what's in the numerator and what's in the denominator. Okay, next example. For this one, we're going to expand this natural log, and we're going to take it as far as we can. All right, so we start with product and quotient. And we see that we have division right away. So let's split this into two logs. And now we can use the power property. And we're not allowed to pull this 2 out on the first term, because remember, the entire thing needs to be squared, not just one term. We can, however, pull the 3 out on the second term, since the entire inside is cubed. So this is natural log of x squared minus 1 minus 3 natural log of x. And we might think that we're done, but that's not the case. We can simplify this one down a little bit more if we factor the inside here. So if we factor x squared minus 1, this becomes natural log of x minus 1 times x plus 1 minus 3 natural log of x. And now that we have multiplication on the inside, we can break that up and make two more logarithms. Natural log of x minus 1 plus natural log of x plus 1 minus 3 natural log of x. And now this is as simple as we can make it. There's no more complex terms inside the logarithm. There's nothing more to factor, and there's no more multiplication. So with this one, we had to do an extra step, and if we ever have a polynomial on the inside, we should always try to factor it, so we can break these down into as simple terms as possible. All right, example 5. As you can see, we're going to condense here. And as we condense, we need to start with the power property and then move on to product and quotient. So power. We're going to take the 1/2 inside the first log and the 3 inside the second. So this becomes log, remember if there's no number it's base 10, of x to the 1/2 power, plus, now this 3 is going to move inside, and the whole part inside the parentheses gets cubed. So log of x plus 1 cubed. Okay, now we've dealt with all of our powers on the outside, so we move on to product and quotient. And the addition on the outside will become multiplication on the inside. So this is log of the square root of x. Remember, fractional exponents become roots. So let's be very specific here and write maybe a 2 to remind ourselves that this is a square root, times x plus 1 cubed, all inside one log. And we've done it. We've condensed this all down, and we have a better understanding of what the inside should look like. Our last example for this is a little bit different. We're actually going to evaluate a logarithm using some numbers to see how expanding can actually simplify this and make it easier to deal with. Now let's try solving this right away without expanding it, and we'll see what the problem is. Remember, if we try to evaluate a logarithm, our first step is to set it equal to y, and then undo the logarithm by moving the base to the other side and making it an exponent. So this is 32 is equal to 4 to the power y. And if we look at the powers of 4, 4 to the first power is 4, 4 squared is 16, 4 cubed is 64, and we have a problem. A problem. "32 is not a nice power of 4. But we can break apart 32 to actually make it to be some nice powers of 4. And what we can do is, instead of looking at log base 4 of 32, we'll look at log base 4 of 16 times 2. 16 is 4 squared, 2 is the square root of 4, so everything works out nicely. Now our multiplication inside the logarithm becomes expanded to be log base 4 of 16 plus log base 4 of 2. And we can deal with each of these. Log base 4 of 16, as we've seen, is going to be 2 from this fact right here that 4 squared is equal to 16. And log base 4 of 2 is going to be 1/2, since the square root of 4 is equal to 2. So these two facts are right here. And then the answer is the log base 4 of 32 is equal to 2.5. If we wanted to write this in a more proper fraction, this would be 5/2, and we have our answer. Either 2.5 or 5/2 is fine. We're just really looking to see what this number is going to be. As far as the properties of logarithms are concerned, these are all the topics. We simply define the product rule, the quotient rule, and the power rule so that we can take logs and expand them or condense them and look at simpler terms. So that's the end of this lecture.